We are covering the principles of airfoil design and lift generation, a critical topic you'll face on the Aviation Information Subtest of the AFOQT. Think of an airfoil as simply the cross-sectional shape of a wing. On the AFOQT, you might see diagrams asking you to identify its key features. The classic design has a more curved upper surface and a relatively flatter lower surface. This specific shape is the entire reason an aircraft can fly. This design forces the air moving over the top surface to travel a longer distance than the air moving along the bottom. To arrive at the trailing edge at the same time, the air on top must move faster. This is where Bernoulli's principle comes into play, a concept the exam loves to test. Faster moving air exerts less pressure, so you have lower pressure on top of the wing and higher pressure below it. This pressure differential creates a net upward force, which we call lift. A typical AFOQT question might present a diagram of an airfoil and ask where the area of lowest pressure is. The answer will always be on the curved upper surface where the air is moving fastest. Now let's talk about the angle of attack, or AOA. This is another favorite for exam questions. The AOA is the angle between the wing's chord line, which is an imaginary straight line from the leading edge to the trailing edge, and the relative wind. As a pilot increases the AOA by pitching the aircraft's nose up, lift generally increases. But here's a major trap the AFOQT will set for you. They'll test your understanding of the limits. While increasing the AOA increases lift, it only does so up to a certain point. This point is called the critical angle of attack. If you exceed this angle, the smooth airflow over the upper surface separates and becomes turbulent. This sudden and dramatic loss of lift is known as a stall. A common trick question might be, what happens when a pilot continues to increase the angle of attack beyond the critical point? The answer isn't more lift, it's a stall. Remember, a stall is an aerodynamic event caused by exceeding the critical AOA. It is not related to the engine stopping. An airplane will always stall at the same critical angle of attack, regardless of its weight or airspeed. To remember the relationship between speed, pressure, and lift, use this simple phrase: high speed, low pressure, high fly. It connects the faster air over the top of the wing to the lower pressure that results in the lift needed to fly high. So on the exam, you'll see these concepts combined. You might get a scenario-based question asking what a pilot should do to increase lift without stalling, which would involve managing the angle of attack. You must be able to visualize the airfoil, understand the pressure differential from Bernoulli's principle, and know the critical relationship between the angle of attack and a potential stall. They won't ask for complex calculations, but a solid conceptual understanding is non-negotiable for scoring high on the Aviation Information Subtest. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.